Superb. All right. I've actually dismantled my desk, so I'm actually sitting on my sofa right now, which is incredibly uncomfortable, actually. But hey, whatever. Okay. Good to see you guys. Hopefully you were with us on Tuesday. On Tuesday, what we covered was looking at equations and rearranging them and manipulating them. All right, so there'll be a wee bit of that tonight again, looking at stuff. We'll use the sort of rules and practice we did on Tuesday a wee bit. But if you missed Tuesday because it was first one back and you missed the dates, etc., don't worry too much about it. It wasn't a huge jump on new learning, hopefully. Okay, there was some new stuff in there, new ways of looking at things. But again, I can give you videos to stuff, okay, so it's not a big deal. Okay, if you missed Tuesday. Plan tonight, go over inequalities, we'll go over simultaneous equations. We'll start simultaneous equations. The simultaneous equations are quite good, all right? They're worth quite a lot of marks, usually in the paper, but there's quite a lot of ways they can sort of ask them. They can ask them in a story, they can ask you a straight question, or they can ask you using straight lines. So we'll look at each of them, we'll break down each of them, and just get a real good understanding of simultaneous equations, all right? As we go through this, again, we'll look at that manipulation of equations and how we rearrange stuff. Okay, so first off I want to look at is something called inequalities. Ooh. Get my pen out of hibernation. Okay, something called inequalities. Okay, so this is when the equations that we're using aren't equal. So the left-hand side doesn't equal the right-hand side. Okay, now that sounds quite weird. So every equation we've been using up until this point has been using this wee equal sign. Okay, we're going to introduce a couple of new signs, okay, or a couple of other signs that change what the equation's telling you, okay? But the way that we manipulate it is 90% the same, okay? So that equal sign means the left-hand side of the equation is equal to the right-hand side of the equation, okay? We can use signs like that, okay? That wee triangle pointing to the right, okay, means greater than. Okay, and we'll look at how we use these in equations as well. There's also a wee symbol like that. So instead of the equal sign, we'll use that symbol there. That'll be greater than or equal to. Okay. Then we've got the triangle when they point to the left, less than, and then left, well, we line under it, less than or equal to. Okay, so just really simply, how do we use that? Well, we can say, how did I manage that? My God. Did I manage that? We can say something along the lines of 5 is greater than 3. As an equation, that's true. Okay, there's no disputing that. Okay, so that's how you use that greater sign. So the left-hand side is greater than the right-hand side. Okay, flip that on its head. Okay, we can say 4 is less than 9. Okay, the number on the left-hand side is less than the number on the right-hand side. There we go. Okay, but again, life isn't that simple. So when we're going to use these, it'll be more, is that algebraic? So something along the lines of 3x plus 7 is greater than 17. That means that when we find a solution on the left-hand side, that solution has to be greater than the number 17. Okay, so it will ask you things like, for what values of x would that equation be correct? Okay, so what number could we put into where that x is positioned for the left-hand side to then be greater than the right-hand side? Okay, so I could say x could equal 9, all right? So when x is equal to 9, 3x plus 7, 3 times 9 plus 7 is greater than 17. 27 plus 7 is greater than 17, so 34. Okay, so that's correct. So when x equals to 9, that could be a solution to that equation. Okay, that's what we're looking for. Remember, these letters that we're using are just variables, they're just unknown variables. Okay, if that was to equal that, that would be a different story. You'd only have one answer, but I could put in a range of answers for that. So x could be a range of answers. So it doesn't just have to be x equals 9, it could be a range of different answers, okay, that fit into that equation. Okay, so to solve these, let's change that. Pen's annoying me. That's a hell of a jump. There we go. Solve an equation. Or writing. You do exactly the same as a normal equation, except, and there's always an except, if you are moving a negative multiple from one side to the other. Okay, so we'll go through examples of that just to show. Okay, so I don't understand how this pen's working. Okay, so to solve an inequation, you treat them exactly the same as we were treating equations on Tuesday. All right, so when we're moving things from the left-hand side to the right-hand side, exactly the same, except when you see a negative multiple that you have to then move across. Okay, so something along the lines of, if you had negative 3x greater than 21, and you wanted to solve that for x, you had to get rid of the negative 3 on the left-hand side and move it to the right-hand side. You would have x, the symbol would flip, so the arrow would flip, and you'd have 21 divided by minus 3. Okay. So in that case, and we'll do a couple more of these, so don't worry. In that case, this symbol flips. Okay, you can see the direction of it flips. When we are, and that's the only occasion, when we're moving a negative, okay, when it's been used as a multiple. So in this case, it's negative 3 times x. Okay, so we're taking that negative 3 and we're dividing the other side by it. When we're doing that, we need to flip that symbol. Okay. So let's do some examples. got 4x plus 9 greater than 2x plus 25. Okay. So, right, we've got 4x plus 9 is greater than 2x plus 25. So similar to some of the stuff we were doing on Tuesday, what we want to do is solve for x. Okay, so the question would be along the lines of solve for x. So we want to get all our x terms on the left-hand side of that equation. We want to get all our whole numbers on the right-hand side of that equation and then solve. Okay, so you can do this in one step or you can do it in 2 steps. Okay, so if you're comfortable with it, leave that 4x on the left-hand side and we're going to bring over that 2x term. Okay, so we're bringing over that whole term. So that's positive on the right-hand side, so it becomes a negative on the left-hand side. Okay, 2x now disappears from the right-hand side, and we're bringing over this plus 9. So 25 is still there. The plus 9 becomes a negative 9. Now we just solve.
Sorry, interrupted, Daniel. My wind was getting so I didn't hear you. Did you say we're gathering the like terms?
Yes.
So that's why you've put the 2x there, aye?
Yep, so you want, when
Right.
you're solving these types of equations, okay, when you're solving for x, so the question would give you something along the lines of solve for x, okay, you want all the x terms on the left-hand side, and you want
Right.
all the whole numbers on the right-hand side, okay, and
Right,
then we just
okay,
tidy it up
thank
as
you.
we go through.
Right, sorry, just in case I missed something important that you said about it. Right, thanks.
No problem at all. Okay, so we're getting to this stage, so we're just tidying up each side. We want to leave x on its own, that's where we want to get to. So we've got x is greater than, and then the 2 is just coming over, becoming a divide. Okay, it's positive on the left hand side, so the symbol stays the same. We're just going to be left with x is greater than 8. Okay, so a solution to that inequality will be when any number greater than 8 is put into that, is substituted into that. Okay, so that's your answer. Okay, so we're taking from that down to x is greater than 8. Okay. Okay, again, solving for x, the symbol we've got in the middle there is the left-hand side is less than or equal to the right-hand side. Okay, so it's the wee arrow pointing to the left-hand side, okay, with the line underneath it, and that line underneath it means it could be equal to as well. So when we find the x term, it could be any term that is equal to that number or less than, all right? So looking at it, again, we want to get all the lettered terms on the left-hand side, all the number terms on the right-hand side, so the symbol doesn't matter, doesn't affect that. That 2x again comes across, 6x stays where it is, 2x becomes a negative, 4 stays where it is, and then the 20 becomes a negative. Okay, so the 20's gone that way, the 2x has gone the other way. Okay, we're just collecting like terms. Okay, that gives us 4x. It's less than or equal to 4 minus 20, which will give us minus 16. Okay. Need to move this multiple across. Because it's a positive multiple, it doesn't affect the symbol. Doesn't matter that the number on the other side is a negative. Give us that. So that inequality there works when the number that's submitted, so when the unknown number that's substituted into that position x is less than or equal to negative 4. Okay, so it's just when that x term is equal to that. If it's greater than that number, then that equation doesn't work. Okay, the left-hand side won't equal the right-hand side. Okay, you don't know that. Okay, similar setup. Okay, 7's coming over this way, 25 is going the other way. Okay, 4x stays where it is, positive over on the right hand side, so it becomes minus 7x, greater than or equal to, minus 7 stays where it is, and you're moving a negative over. Okay, so that symbol's really important. That becomes positive on the other side. Okay, if you wrote that 25 minus 7, it's the exact same thing. Okay, so the order of that side doesn't matter. Okay, I usually take the number that's left and take it right closest to the symbol, but whatever you're comfortable with. Okay, if you'd written that 25 minus 7, it's absolutely fine. 4 minus 7 on the left hand side, 4x minus 7x on the left hand side, give us minus 3x. Symbol stays the same currently. Okay, minus 7 from that is 18. Okay, and now we're left with the first example where we've got a negative multiple on that left hand side. Okay, so we're wanting to leave just x on the left hand side. So we need to move that negative 3 over to the right hand side so we can isolate that x, so we can leave it on its own. Okay, that negative 3 is a multiple, negative 3 times x on the left hand side, so it becomes a divide on the right hand side. Okay, remember, change side, change sign. But because it's negative, and only because it's negative, that sign flips. Okay. And put a nice big star because the multiple negative. Okay, everything else we do, any other numbers, additions, subtractions, any other positive multiples that we move left to right, okay, symbol doesn't switch. Only when we've got a negative.
Is it only about a negative on the left?
Yeah,
'Cause
because you're
probably-
only, so because we're trying to leave x on its own,
Right,
you're
aye.
going to take all the x's over to the left hand side first. So you're
Right.
only really going to take a multiple of x back across. But if for whatever reason you'd left with a number term on the right hand side and a whole number on the left, and you were taking that multiple across, you would still flip.
Right, thank you.
Okay, I'm going to write 3 down, and I'll give you a wee second. Let's see who's saying something in the chat. So someone's asked, could you also write less than or equal to negative 4 is less than negative 5? No, because you still need to state that it could be negative 4. The answer could be negative 4. Now, I see where your head's going. So if it was only less than negative 4, you could say less than or equal to negative 5, but that's dangerous territory. Okay, so I see what you're thinking, it's logical, but no, don't. All right, so give these a wee try for 5 minutes. X plus 9 less than or equal to x minus 11. That's a pen, honestly. Greater than or equal to 10x plus 7. And 3. 7x plus 40. Greater than or equal to 12x minus 5. Okay, give them a wee shot. I'll just pause my recording for a wee second. Okay, then we'll come back together. What's the time? 34. Say, just take a couple of minutes doing that, okay? So come back together at 39. In fact, just come back together at 40. Okay, so 6:40, I'll come back on, okay?
Will you leave that on the screen so we can see it?
Yeah, I'll leave that up.
Yeah, thanks.
Very nice one. Okay, so going quickly through it. See if I've got room actually. 3x minus x over this side. That 9 will go across, become a minus as well. So 3x minus x will be 2x. That'll become minus 20. X be less than or equal to minus 10. Okay, so minus 20 divided by 2. Okay, I've just run out of space there. Okay, so x less than or equal to minus 10. Okay, 6x minus 10x greater than or equal to, that minus 21 goes to the other side, it becomes 7 plus 21. That'll be minus 4x greater than or equal to positive 28. Leaving x on its own. Okay, we're taking a negative across. Flips that sign. 28 over negative 4. Okay, x negative 7. Okay, so that's your final answer there. Just run out a wee bit of space. Okay, so that's the first one without changing that symbol. Okay, 7x plus 40 greater than or equal to 7x minus 12x greater than or equal to minus 5 minus 40. Okay, 7 minus 12x given negative 5x. Okay, a bit messy. Okay, and that'll be negative 45. That negative 5 gets moved over. Because it's a negative, the symbol flips. The negative 45 divided by negative 5. A negative divided by a negative will give a positive. Will give you positive 9. Okay, so there's a few things that might catch you there. In regards to inequalities, that's essentially it. All right. Okay, I'll just do one wee step up where they could make you break a bracket, possibly. Okay, so I'll do a couple of examples of that. But in essence, once we come to do past papers, it's just those rules that we follow. Okay. Any questions on those three? We good? Okay, so past papers, type of questions that have come up, okay, type of format they've come up. So 3x less than or equal to, and they've thrown a bracket in there. Okay, they've thrown a bracket in there. A couple of ways you could approach this. Okay, one of the easiest ways is actually to break that bracket, and there's not a lot of occasions where I'll tell you to do that when we're simplifying things. But I'm going to say probably the easiest way in this occasion would be break that bracket, collect the like terms on the right hand side, tidy it up a bit, and then move all your x terms over to the left hand side. Okay, so that's the tricky bit here. So if we say 3x, we'll just keep that as is, less than or equal to it, and we'll just break that bracket as we normally break brackets. 6x minus 6, and that negative 12, nothing happens to. That's outside the bracket, that's completely separate. Okay, then we're just tidying up that right hand side. Greater than or equal to 6x, that would be minus 18. And now that's in the form that we sort of know. Okay, so we can take that x over to the left hand side. 3x stays the same. The 6x term is positive on the right hand side, so it becomes a negative. Okay, change side, change sign. That. That'll give us, tidying that up, negative 3x. And then we want to leave x on its own, completely on its own. Oh. Negative 18 divided by negative 3 would give you positive 6. Okay. Now, there's another way to do that where you take the 12 across, so it's 3x plus 12, then you take the 6 across and divide both, and it just gets a wee bit messy. Okay, I'm not going to do it tonight, but maybe when we're going through past papers, if we see it again, you might try it and it might come up in conversation. Okay, but in this regard, that's quite an easy bracket, quite a simple bracket. You can sort of see as soon straight away, if I break that up, I'll be left with a whole number, an x term that I can get rid of. Okay, so it's just sort of practice and getting used to these sort of formats. Okay, take that across. Practice one more of them, and then we'll move on to simultaneous equations. Okay. So say 11, so say another example, 11 minus, and then another bracket, 1 plus 3x. Okay. Typically, in past papers, that's the type of format that I've seen. Okay. So again, looking at that, straight away, I want to be left with x terms on the left-hand side and a whole number on the right-hand side. Okay. What I want to do is break that bracket up. Get rid of that bracket, so it's just whole numbers and x terms, and then we can move that across. Okay. So I'm just going to do that. 11, and then whatever's outside that bracket, so in this case minus 2, it's just multiplied by each of these terms. So remember that minus sign. Okay, minus 2 multiplied by 1, then minus 2 multiplied by positive 3x. Okay, so just remember that minus sign on the outside of the bracket. Okay, so whatever that number is, multiply it by both terms. So you've got minus 2 minus 6x. Okay, just be careful with that. Tidying that up. Okay, then we can take the 9 over. okay? Lots of room of silly errors, okay? There's nothing that we've not done, not seen. They're quite easy, but there's lots of room for wee basic errors, okay? So minus 6x less than 30, taking that minus 6 across, x, that flips, 30 divided by negative 6, oops, x is greater than negative 5. Okay. Any questions there? No, good. It's just a wee thing to remember in that exam. Good man, Dylan. Okay, superb. That is inequalities. That's it. All right. Okay. Let's have a wee look and talk about simultaneous equations. Okay. You'll be glad to know that in the exam you won't be asked to spell simultaneous.
I was pure loving spelling that there. It's doing nice things. It's like therapeutic. I don't know why.
Well, I hated it. All right. So simultaneous equations, why do we use them? Well, we can use them to solve either two equations that both have two unknowns. That will make sense when we look at a couple of examples. Okay, two unknown values in each. Okay, so we're using them to find these unknown values. Okay, we're using them to solve those equations. Or, okay, finding the intersection okay, I'll write the coordinate, it's usually coordinate of two straight lines. Okay, so the coordinate at which two lines intercept each other, cut through each other. Okay, that's specific coordinate at which they do that. So it goes back to the stuff we were doing at straight lines. Okay, when we were looking at the straight line equation where it was y equals mx plus c. Okay, so y equals the gradient times x equals where it cuts the y-intercept. Okay, so we'll have two of those types of equations set out in those forms. Okay, or you'll get shown a graph and you'll need to calculate what straight line equation is and then work out the unknowns or work out where the intersection is. Okay, it's potentially worth quite a lot of marks, that question. Okay, so method I'm going to teach you, it's called elimination. I can't even spell, oh god. Let's start that again. Okay, so there's two methods that we can do. I prefer the elimination method. Okay, now if you were taught the other method in school and you prefer the other method and you're comfortable with the other method, and you don't like this one, I don't mind. Okay, if you study that one, okay, or if you've got a tutor and they tell you another way of doing it and you're comfortable with it, both work. Okay, you can do both in the exam, they're worth the same amount of marks. Elimination, I'm going to teach you one method so I don't confuse you. This is the method I like. Okay, If you really don't get it, we can have a wee look at the other one. Okay. So you're going to get given two equations. Okay. Something like 3x plus 2y equals 12 and 4x equals. Okay. So equation 1 and equation 2. Okay. Now the first part of the elimination method is you want to put them one above each other. Okay, one above, one below, vertically. And you want to have the x terms lined up. Sorry, one of the letters lined up, the other letter lined up, and the whole numbers lined up. And you want all the letter terms on the left-hand side and all the whole numbers on the right-hand side. I say letter terms because they sometimes like to tell a story where instead of using X and Y, they'll use A and B, R and S, okay? And you'll see that exact same process, okay? These letters are just means unknowns, okay? So you'll get given two equations. You want to first make sure all the letter terms are on the one side, okay? So letter terms, all the unknowns are on the one side, okay? Preferably in alphabetical order, but because of the way we're going to set it out, you want them one above each other. So instead of that 1 and 2, the form that they're in, I would keep number 1 the same, okay? But I would bring that y term over to the other side, over to the left-hand side for that second equation, okay? And I would write it 4x plus 3y equals 16, okay? So all the letter terms, all the unknowns are on the left-hand side, and all the whole terms on the right-hand side. Now what we want to do, okay, so step 2, okay, so step 1 above. Step 2, want to make the number in front of one of the letters, one of the unknowns, in front of one of the letter terms the same in both equations. Okay. So step 2 is using those exact same formulas, okay, those equations, equation 1 and equation 2. Okay. I want to make one of the numbers in front of the letter terms the same. So these letter terms, y, okay, both y's, we want to change that y, that number term to equal the same. And we do that by a process of cross multiplying. Okay, so we multiply equation 1 by the bottom number, and we multiply equation 2 by the top number. So make the number in front of one of the letter terms the same in both equations by multiplying by, I'll call it cross multiplying, by cross multiplying. Okay, so that means equation 1, you multiply that whole thing by 3. So equation 1 would all be multiplied by 3. We get 9x plus 6y equals 36. And equation 2 would all be multiplied by 2. So I'd get 8x plus 6y equals 32. Okay, so that's equation 1 still, that's equation 2, but because I've multiplied it, that's why we're getting bigger numbers. Now you'll see now that term in front of the y's is the same in both equation 1 and equation 2. Okay, so remember what we're wanting to do is eliminate one of the unknowns so we can solve for 1. Okay, so we can solve. So in this case, I'm solving for x by trying to eliminate y. Okay, so I'm eliminating those y's. And the way we do that, step 3, is we can add or subtract. Okay, and that becomes important later. Add or subtract the equations vertically to eliminate one of the terms. Okay, so we're going to take equation 1 and 2, and the way we've written them out is all the x's are in a nice column, all the y's are in a nice column, equal sign, you always get equals, it will always be equals, okay, and then the whole numbers. Okay, so that's the way we're doing it. 1 letter, 2 letters, whole number. You only ever get two letters, okay. 9x plus 6y equals 36. 8x plus 6y equals 32. I'm going to draw a line under that, and I'm going to say subtract. So what I'm going to do is I'm going to subtract the bottom one from the top one. So I'm going to do 9x minus 8x, give myself x. I'm going to do 6y minus 6y, to give myself 0 there. That eliminates that. And I'm going to do 36 minus 32, give myself 4. Okay, so that's a nice easy solve. X equals 4. Okay, that's my first solution. I've solved that equation for x. Okay, but now I want to find the other unknown. So that's me solved that equation for one unknown. X equals 4. Okay. Find the other unknown. Okay, in this case, the letter y. Okay, find the other unknown.
Sorry, is it not step 4?
Yes. Hope if I could count to 4. That's a bad sign. Find the other unknown by substituting in. To one of the equations, and it doesn't matter which one. The solution in step 3. Okay, so I'm going to take that x equals 4. Okay, x equals 4. I'm going to substitute into the original equation 1. Okay, so that original equation 1 was 3x plus 2y equals 12. Okay, just trying to check that. 3x plus 2y equals 12. Okay. So that original equation was 3x plus 2y equals 12. I want to substitute the fact that x equals 4. So where I see the letter x, instead of writing the letter x, I'm going to write the number 4. So instead of 3 times x, I'm going to get 3 times 4. Okay, so substitute x equals 4 in. So I'm going to write it with 4 in the bracket. Okay, 0, 3 times 4 plus 2y. That's the exact same. Okay, that's fine. Okay, you wouldn't lose any marks. I just like to keep it in a bracket. So 3 bracket 4. That just means any term outside the bracket, I'm multiplying with the one inside the bracket. Okay. 3 times 4 is 12 plus 2y equals 12. Okay, so y is going to equal 0. 2y equals 12 minus 12. Okay. 0 divided by n is going to be 0. Okay. So my solution, my answer, okay, so x equals 4, y equals 0. Okay, now I said it doesn't matter which one you use. Okay, so I'll show you that. We could have used 2. Okay, so 4x equals 16 minus 3y. We could have used that equation as well. Okay, so if you've got time in the exam, you could even check that. 4x equals, Christ, I forgot already. But 3y, 4x, 16 minus 3y. Okay. If I was to substitute those terms in, we get 4 times 4 equals 16 minus 3 times 0. 3 times 0 is going to be 0, so 16 will just equal 16. So my check's done. So if I substituted both those numbers into that original equation, what that tells me is correct. Okay, so the left-hand side equals the right-hand side. Okay. Let's go through some more examples. 6x plus 5y equals 9. X minus 5y equals 2. Equals 19. Okay. That's my equation 1. That's my equation 2. Now, we can see we want to go through a process of elimination. So we've lined them into vertical columns. That term in front of the y is the same as that term below it, okay, in front of the y. One's positive and one's negative. So I said in step 3, that I can add or subtract the bottom line from the top line. Okay, so in this case, if I add the bottom line to the top line, then it will do the same elimination process. Okay, oops. So if I do the same thing, put a line under that, say add, and then I'm adding them together vertically. Okay, 6x plus x is going to be 7x. 5y add negative 5y is going to give me 0. It's going to eliminate it. Okay. going to be 5y minus 5y. Okay. It's going to equal 0. So you can take it to the right hand side if you want and do that. You won't lose any marks. That's what I mean by that. Okay. So if I add both those terms together, it eliminates that. Add both the last terms together, 9 plus 19. It's going to give me 28. Okay. And then we can solve for x. Okay. Then we can follow through and solve for x. Okay. So x is equal to 28 over 7. X is equal to 4. Okay. So in the last one we subtracted, and this one we're adding. Did we subtract? Yeah. Okay. So we can add or subtract that second line. We're just trying to eliminate one of those letters. Okay, in this case the number was the same, so we just had to go straight into it. Okay. Substitute. Find the other unknown. X equals 4 into equation 1 or equation 2, up to you. Okay, so equation 1 was 6x plus 5y equals 9. Substituting the number 4 into that. So 6 times 4 is 24. Nine minus 24 is minus 15. Y is minus 15 over 5. Y is equal to negative 3. Okay. You could have substituted that into equation 2 and get the exact same answer. Okay, so whatever equation looks the simplest, and again, that comes from experience when you've looked at a couple of these. Okay, whatever equation looks the simplest, you can do. Okay, so just to show that, I'll substitute x equals 4, okay, into equation 2. Okay, equation 2 was x minus 5y equals 19. Okay, x equals 4, so 4 minus 5y equals 19. Minus 5y equals 19 minus 4. (15) divided by negative 5, y is equal to negative 3. Okay, exact same answer. So you can substitute that into either, you'll get the same answer. So your final answer, x is equal to 4 and y is equal to negative 3. And then again, you can substitute into other equations, or you can check those answers by substituting. If you've got time at the end of the exam, it's worthwhile doing just for a wee check. All right, we'll do it on a separate piece of paper, you don't need to show anyone. Okay, example 2. Any questions on that so far with the elimination method? You're good. Okay, how about 4x plus 5y is equal to minus 7. 3x plus 2y is equal to minus 7 as well. Okay, that's your equation 1. That's your equation 2. So you can see we've got x terms in a nice column, y terms in a nice column, and you've got the whole numbers in a nice column. Okay, now again, we're trying to find the unknown, so we're trying to find the x term and the y term that allows both of these equations to be correct. Okay, for the left hand side to equal the right hand side. Okay, because none of the numbers are the same, we're going to have to do that multiplication process. So we're going to have to multiply equation 1 by the number in front of y. It doesn't have to be the number in front of y, it could be the number in front of x. For whatever reason, I prefer doing y. Okay. Multiply by 2. That term up there, I'm going to multiply equation 2 by that term. So I get the same number in front of the y's as I do in front of the x's, in front of the y's. Okay. So top term multiplied by 2 will give me 8x plus 10y equals negative 14. Bottom equation multiplied by 5 is going to give me 15x plus 10y equals negative 35. Okay, and just be careful that you're multiplying every single term. Okay, don't forget any. That means I can do my elimination by subtracting.
Daniel, sorry, see, know how you're timesing the equation 1 by 2, would it not be like positive 14 because it's 2 negative 7s, no?
No, it'd be negative 7 times 2, so it wouldn't be a negative multiplied by a
By
negative.
itself, right, okay. Aye, right, okay.
If it was negative 7 times negative 7, then yeah, you'd be correct.
I know I'm thinking like timesing it. I don't know why I'm thinking about timesing it by itself. I hope you're not recording me. Please take my voice out of this because I'm actually talking so much rubbish.
Don't worry. I'm absolutely not editing this video, so you're in it. So subtract the top and the bottom. All right. 8 minus 15 would give us negative 7. 10 minus 10 would give us 0, so that eliminates that. Negative 14, negative 35, so we're taking away a negative, so it becomes a positive. Okay, so just be careful with that. It becomes 21. Okay, so we'll just again do that over the right hand side. Negative 14, we're subtracting negative 35. Okay, that becomes a positive when we're doing that. Okay, so just be careful with that. Okay, gets a wee bit messy. Negative 7, tighten this up then. Negative 7x equals 21. X equals 21 over negative 7. X is equal to negative 3.
Where are you getting that 21 for?
So negative 14, take away negative 35. So I'm taking away a negative.
Oh, right, aye, yeah. So you're hiding it, right, okay.
It's, yeah, can catch you out. So just be very, very careful. Okay. So because we're subtracting, that negative becomes a positive and it becomes negative 14 plus 35. Right. Sub into 1, so substitute that into 1. Okay, 1 was 4x plus 5y equals negative 7. Okay, so 4 multiplied by negative 3 plus 5y equals negative 7. So that'll be negative 12 plus 5y equals negative 7. 5y equals negative 7. Taking that across becomes a positive. change side, change sign. 5y equals 5. Y is equal to 5 over 5. Y is equal to 1. Okay. Answer. Oops. Any questions on that one? This one. Cool. Right, let's have a wee go. Example 3, I think. Okay. Question will be along the lines of solve, or it might give you a wee story, or it will ask for a coordinate. Okay. So they might use different letters, so just be aware of that. So I'm just going to throw this one out. 2a plus b equals 10. 3a minus 4b equals 26. Okay. That's our equation 1. That's our equation 2. Okay. Just because they're different letters doesn't change the process. Remember, letters in algebra, just mean unknowns. So A is an unknown, just like X was. B is an unknown, just like Y was. Okay? These letters just stand in the place. All good. Okay. Solving's the same then. So we are looking to get to the point where the number in front of, let's say the B terms again, the same. So if I multiply that by 4, and I multiply that one by 1, okay, so whatever number's in front of that, put here. Whatever number's in front of that, I'll put here. Okay, so that equation 1 multiplied by 4 would give me 8a plus 4b equals 40. That'll give me 3a minus 4b equals 26. Okay, so that second one doesn't change, so we're multiplying it by 1. Okay, but that now gives me the same number in front of the b terms, okay, for equation 1 and equation 2. Now, remember we can add or subtract the bottom from the top, so we don't have to change negatives and stuff like that, so we don't have to multiply by -4 on the top. Okay, it just means that when we come to it, we need to add these terms together. Okay, so if you've got +4, you need to add that -4 on. Okay, adding a negative will take it away. Okay, so just be careful with that. Adding them together gives us 11a equals 66. A would equal 66 over 11. A would just be 6.
So how do you know when to add or subtract? Because I just went to subtract it, and it didn't work.
It's what these symbols are here.
Right.
So if the top ones are positive and the bottom ones are positive, then you need to subtract
Right.
the terms. If the top one is a positive and the bottom one's a negative, then you need to add them together. Okay, so if you're adding a negative to a number, then you're essentially taking it away. So
Right.
if you're +4 plus -4, then you're actually 4. Okay. It's a wee bit messy, but when you get used to it, it does make sense. Okay, so just watch out for those symbols. So it's only, you only subtract when the top and the bottom are both positive or both negative. Okay, sub that into 1. 2a plus b equals 10. 2 times 6 plus b equals 10. 12 plus b equals 10. b equals 10 minus 12. b is equal to minus 2. Okay, so that answer Any questions on that, guys? Nice one. Okay, what I'm going to do is give us a wee 10-minute comfort break. We'll come back together at 25 to. Okay, so just take 10 minutes, get your head round what we've just written up. Okay, then we'll come back together at, what did I say there, 25 to. Okay. Right. Record. Nice one. Okay. Right, so past paper style question about straight lines. It'll give you something along the lines of, could give you a graph with showing 2 straight lines. It could give you a graph where you have to calculate the equation of the straight line. So we did that just before Christmas. Okay, so look back at that if you want to go over that. Okay, essentially they'll give you 2 equations. So 3x minus y equals 2. X plus 3y equals 19. Okay, the question will be along the lines of, for the 2 straight line, for the 2 straight lines outlined, find the point of intersection. Okay, all that's asking you to do is, if you've 2 straight lines that cut across each other, find the point at which they meet. Okay, find the point at which they cross. Okay, so that will be on an XY coordinate graph. Okay, so it will come with an X, Y. So when we find our X and Y's using our method that we've worked out, okay, when we find our X and Y, we'll put it in coordinate form. Okay, that's all it's asking for there. So they'll give you an equation, or you might have to work out the equation of a straight line and then rearrange it to allow you to do these simultaneous equations. Okay, so for the 2 straight lines outlined, find the point of intersection. Okay, so I'm just going to rewrite these equations. 3x minus y equals 2. X plus 3y equals 19. That's my equation 1. That's my equation 2. Again, I'm going to put the same number in front of the y terms. So I'm going to multiply that top line by 3. And I'm going to multiply that bottom line by 1. Okay. Again, we just need to be careful with the signs as we go through this. That top term is going to go to 9x minus 3y equals 6. Okay, that bottom term stays x plus 3y equals 19. Okay. Adding those terms together, we're going to get 10x. We're going to negative 3y plus 3y. Okay, that's going to eliminate them. Then I'm going to get 25. Okay. In this case, you can either simplify down, put it into fraction form. Okay, so 5 goes into the top line 5 times, goes into the bottom line twice. Or we can write it in decimal form. So 25 divided by 10 is going to be 2.5. Okay. Now that's a wee bit difficult in respect to there's a decimal there, but you'd be expected to do that sort of level in a non-calculator. Okay, using that without a calculator. Okay. So that's our x term. So our x as a coordinate is either going to be x equals 2.5, or we could write it as a fraction, x equals 5 over 2. Okay. We're going to substitute that in. One of our terms. Okay, so if I substitute that into, let's go 1, just to make life hard for ourselves. Okay, substituting that into 1, I've got 3 multiplied by 2.5. Okay, minus y equals 2. Okay, so it's gone into the original equation we had. Now we need to do 3 times 2.5. Again, because there's a wee decimal in there, make things a wee bit more difficult. But that level of multiplication you should be able to do. Okay, so 2.5 times 3. Okay, so you've got 2.5 plus 2.5, which is 5, plus 2.5, which is 7.5. Okay, so your answer would be 7.5 minus y equals 2. Okay, minus y equals 2 minus 7.5 minus y equals minus 5.5. Y would be minus 5.5 over minus 1. Okay, so remember in algebra we don't write it. It would be a wee 1 in there. So we're moving minus 1, the multiple minus 1 across the other side. It becomes divide. It would be 5.5. Okay, so a little bit more difficult. Again, you could do that with a fraction and work your way through a fraction. Okay, so if we substituted the fraction into equation 1, we'd have 3x minus y equals 2 plus 3, then 5 over 2 minus y equals 2. The 3 times 5 over 2 would be 15 over 2. Okay, so that goes back to when we did fractions, when we multiplied fractions out. Okay, so remember, multiplying a whole number with a fraction, you're multiplying that top term, so it becomes 15 over 2 minus y equals 2. Okay, minus y equals 2 minus 15 over 2. Again, going back to when we did fractions, we took away fractions. Okay, it wasn't that long ago. To tidy up that right hand side, instead of writing 2 on its own, I can write that as 2 over 1. Okay, so any number on its own, you can divide it by 1 and you'd get the same number. Okay, so if you wanted to write any number on its own as a fraction, just divide it by 1 like that. Okay, and that means you can tidy that up a wee bit by doing our subtraction of fractions. Okay, when we do the kiss and smile. So you multiply 15 and the 1, the 2 and the 2. And then you'd multiply those bottom terms together. Uh, 4 minus 15 is minus, it's getting late, minus 11 over 2. Taking that negative 1 across, you just multiply that bottom line, so it'd be negative 2, which would be 11 over 2, which is, if you divide 11 by 2, you get 5.5. So it's the exact same, but just in fraction form. Okay. A wee bit tough, but nothing we've not seen before. Okay, it just takes a wee breath, take a step back, think about what it's asking, and just go step by step through it. Okay. You have done these calculations before. It's just putting it into a different context that makes it a wee bit complicated. Okay, so don't get tricked by the fact that it's putting it into another context. They can put something like this in just to throw you a wee bit. Hopefully they don't. Hopefully they keep it nice and simple. Okay, but just be aware you might have to cross sections. Finish that answer off. It's asking you for the point of intersection. So it's asking you for a coordinate. Go on. So it's asking you for coordinate or okay, in the form of x, y. Okay, so just leave your answer like that. So your answer to that question would be the coordinate 2.5, 5.5, or 5 over 2, 11 over 2. Okay, both are the same, both are the correct answer. Okay, you can leave it in fraction form, it's not a problem. It's just a bit of a pain in the arse. Did the more complex one first. Got them on the same piece of paper. Okay, I'll just do one more example, and again, then I'll send you the booklet. If you want to spend a wee bit more time tonight, or if you want to call it a night, that's fine. Okay. This is actually a simpler one. I did the wrong one first, but we'll go for it. Okay, so again, in fact, you know what? I'll give you 5 minutes to try this yourself. Find the intersection of the straight lines five x equals 4y plus 22, 3x plus 5y equals minus 9. Okay. Have a wee go at that for 5 minutes, try and get as far as possible. Then I'll come back on, we'll just go through that answer and then we'll call it a wee night there, okay? So take up until 8 o'clock, then I'll come back on. Okay, nice one. Okay, so two equations there. Equations of straight line, we've seen them before. Okay, they're a wee bit of a more complex format, so we need to do a wee bit of rearranging for the first one, and then we'll put them on top of each other. Okay, so rearranging that first one, that first equation, the 5x equals 4y plus 22, we want all the letter terms on the same side. Okay, so we want the 5x and the 4y over the same side. So 5x minus 4y will equal 22. Okay, that will be your first equation. And that 3x plus the 5y equals minus 9. Second equation stays the exact same. Okay. We now want to make the numbers in front, and we'll stay consistent, we'll just numbers in front of the y terms the same. Okay, so I'm going to multiply that first one by 5. Okay, I'm getting that number from here. I'm multiplying that bottom one by 4. And again, I'm getting that number from the opposite equation. Okay, so I'm multiplying everything in that first equation by 5, every single term. And I'm multiplying everything in that second equation by 4. Nine, 18, 36. Okay, to get that, my two equations. So I've got the x terms on top of each other, the y terms, and the whole numbers. Okay, I'm going to add both of these together to eliminate. Okay, so I'm getting 37x here. The minus 20 plus 20 is going to rule each other out, so it's going to eliminate that. And the 110 plus the negative, okay, so I'm taking that away, I'll get 74. Okay. How are we doing so far? You see where we've gone wrong, or good?
Aye, I've seen where I went wrong. I had mixed them up, like instead of like I've actually wrote on my paper the first one times it by 5 and then the second one times it by 4, and then while I've been doing it I thought that's been wrong, then I've scribbled them out and then switched the numbers back.
So you're doing it right, and you lost
Aye.
It's not too uncommon. Dylan, see your comment, was that about this? What was your comment? X negative 4 times by negative 4. So you can, but to keep things consistent, so I'm not confusing, I prefer just to multiply by the positive numbers and then do the add or subtract part. All right, so you could make them both positive, the numbers in front of the y, and then subtract them. If you like that method, that's fine. I'm going to stay consistent with this, so I'll keep it as multiplied by 4, and that keeps the numbers the same, but the symbols can be different. All right, that's why there's a add or subtract option. Good man, cheers. Okay, so 37x equals 74. So 37x equals 74. X equals 74 divided by 37. Okay. Shouldn't need to know your 37 times table, but 37 times 2 is 74. So I'll just give you 2. Try to see if there's an easier way to simplify that, but there's not really. It's just a case of if you get something that looks like that, just see what happens when you double that bottom number or triple that the bottom number. Okay, if you try and get that number. All right. So we get x equals 2. We'll minus that. Substitute that into either. Okay, so substitute that into 1. Will be 5x minus 4y equals 22. 5x would be 5 times 2 minus 4y equals 22. So 10 minus 4y equals 22 minus 4y, 22 minus 10 minus 4y, okay, equals 12. Y equals 12 over minus 4. Y equals, pardon me, minus 3. Okay.
Why is it like, say normally when you're moving stuff to the other side that it changes? Why is it always when it's a negative? Is it just because it's before the letter?
Yes, so because that's before the letter, that negative 4, that means
Is it-
it's negative 4 multiplied by y,
Right.
right? So when I've got something multiplied by something else, when I'm moving that term,
It only changes
moves
to
that
divide.
negative, all right? So when it goes from multiple to a divide, so change sign, so it's going from multiple to a divide, but the negative stays. It's only when it's an addition or a subtraction. So if I took that number 10 across, that's positive 10 on the left-hand side, so it becomes negative 10 on the right-hand side. Right? So just be careful with that.
Right, so when it's known front end and then basically.
Yeah. So if you're just moving part of the multiple,
Right.
it doesn't change sign.
Right, okay. It's right, aye, that's fine. Thank you.
The change sign part in that case, when you say change sign, is the multiple changing to divide.
Aye, I was just going to say that it's changing like what it's doing instead.
Aye, it's changing what it's doing.
Right, thanks.
Cool. So just to finish that, just to put it in, remember, put it in the coordinate. So the coordinate would be x2 and y is minus 3. And that would be your final answer. Okay. What's the time? So,